Hello, Hornets. In this video, we're going to be taking a look at how we take the derivative for an arctangent and an arcsecant. And I'm going to do both of them in this video. So all we're trying to do is get the derivation. What's the formula for these? And to do that, we're going to start in the same place that we did before. So we're going to take ddx, and we're going to have the arctangent of u. Now take note that I'm using the tangent of the -1 just so that we get the diversity and get used to seeing our arctangent, arcsecant, arcsine, arccosine, and arccotangent in the different forms that we have them. All right, so when we do this, just a reminder, we're going to set this equal to y, and we have the arctangent of u. We're going to move the tangent to the other side, and that's leaving us with the ratio u divided by 1. Now we need this ratio so that we can set up our reference triangle in terms of y. This is the opposite over the adjacent, and therefore our hypotenuse is 1 plus u squared. Now with this, we can now take our derivative of both sides. We know we're going to get a u prime, and we know we get the secant squared y. And I'm going to go ahead and just put my dy dx in front, as I am going to divide and have dy dx is equal to u prime over the secant squared of y. But that means we need the secant of y first. So let's find out what the secant of y is. It is the square root of 1 plus u squared divided by 1. And therefore, secant squared y has to be 1 plus u squared. I'm going to do a direct substitution now, and I end up with my formula or derivation. U prime is equal to 1 plus u squared. And that's what we will use. When we're working with the arcsecant, please be aware there is no agreement. In other words, there's lots of disagreement about the negative arcsecant and the negative arccosecant. Because there is no convention that we can work with, we are going to be using an absolute value to maintain a positive value for the first and fourth quadrants. So let's take a look. We've got d dx. We're working with the arcsecant of u. Once again, using our term u, could have used secant to the -1. We're going to let y equal the arcsecant of u, and therefore the secant of y is equal to u divided by 1. Notice I'm trying to get to that ratio so that I can set up my secant. That means that I have my hypotenuse over my adjacent, and you'll notice that the hypotenuse is a positive. U is a positive radius here. That's one of the things that they're looking at and why they're going to make this an absolute value. So here we go. Our hypotenuse being u and 1 being the adjacent means that I have u squared minus 1. All right, let's just go through. What do we get when we take our derivative? U prime on the right side, and we have a secant y tangent y. Let's just look at what secant y is. Secant y is u divided by 1. We saw that right here. Tangent of y is now the square root of u squared minus 1 over 1. And by direct substitution, I'm going to get u, don't forget your dy dx, Mr. Lamb. So we have dy dx is equal to u prime divided by secant y tangent y, and we can now do a direct substitution. Dy dx, u prime, u square root, u squared minus 1. Now, a couple of things to keep in mind. Remember, there's no agreement for the negative secant and negative cosecant. So we're going to put absolute value around it. This will also account for this u value being a radius, and a radius is always positive. So if you can remember that radius is always positive, or that we aren't working with negatives, with the arcsecant, you won't have a problem. And this is the formula that we're working with. Now, the only difference between the tangent, the arc tangent and the arc cosecant, is that cotangent and cosecant both start with c. And as we've said, anytime we're trying to take the derivative of a trig function that starts with c, we're going to have a negative. So we know that that means that the derivative for our arc cotangent of u d dx is going to have to be the negative u prime of u squared plus 1, and the d dx of our arc cosecant of u is going to have to be negative u prime divided by absolute value of u times the square root of u squared minus 1. Now, a couple of things to keep in mind of when you're looking at these, notice that the arc secant and arc cosecant have an x squared first, whereas the arc sine and arc cosine have the 1 first. So it's 1 minus u squared as opposed to u squared minus 1. And these are the formulas that we're going to be utilizing and that you must know and be able to work with. In the next portion of my video, what we'll be taking a look at is how do we use these formulas, specifically the secant, the tangent, the cotangent, and the cosecant, in order to find our derivatives. As we saw before, we're going to be using this formula exactly as we see it, identifying u and u prime. So that's what we'll see next. Thank you, Hornets. I hope this made sense, and please let me know if you need more. Thank you. Be well, be safe,